We've already looked at solving equations, but when you get an equation with two unknowns in it, you can't solve that. You can only solve an equation if there's just one single variable in it that you don't know the value of. If there are two unknown values, then you need two equations to solve them, and it has to be two equations giving different information. So, for example, if you know that x plus y equals 10, you've got loads of solutions to that. If x is 1, y is 9. If x is 2, y is 8. If x is 3, y is 7, and so on. And that's without even thinking about halves and quarters and decimals and negative values. So in fact, there are an infinite number of solutions. But if you also know that x plus 2y equals 14, then you can look at the two equations side by side and use that to find a single set of solutions for x and y. Here's an illustration of this particular example using a bar model. So we've got this unknown value x and this unknown value y that sum to 10, add up to 10. So that's your x plus y equals 10. And then we've got another x, and this time two y's, and they add up to 14. And if you look at the difference between those two equations, it's this bit here, isn't it? Difference is y. And if this one adds up to 10 and this one adds up to 14, then the difference is 4. So y equals 4. Now doing it algebraically, x plus y equals 10, x plus 2y equals 14, that's this and this. Let's just swap them over so it's easier to do the subtraction. You don't have to, it just makes it a little bit easier to see what's happening. So we'll put the x plus 2y at the top and the x plus y underneath. Now if we take away that whole second equation from the first one, notice I put the minus sign at the right hand end, because if you put it here, it can look as if you've got negative x plus y, which is not what we've got. Then we get rid of the x, because x minus x is 0. And 2y minus y is just y. And 14 minus 10 is 4. So you're left with just y equals 4. And we call this eliminating the x. So we're eliminating whichever variable we've got the same number of. So we've got 1x in this equation and 1x in this equation. So we can take them both out. Now that we've found what y is, we can substitute that back into either one of the equations, whichever's easier, to find x. So if x plus y equals 10, then x must be 10 minus y. And we know that y is 4, so x is 10 minus 4, which gives us x equals 6. And it's always a good idea at the end to substitute those solutions back into the other equation to check that you've got the right solution. So x plus 2y, x is 6, y is 4, so that's 6 plus 2 times 4, which is 6 plus 8, which is 14. And that matches this equation, so we've got it right. Now some for you to have a go at. Pause the video, work out your answers, and press play when you're ready to go through them. And the answers. For number 1, x is 5 and y is 3. For number 2, a is 2 and b is 7. And for number 3, x is 5 and y is negative 1. If you got all those right and you're happy with them, great, you can end this video here and go on to the next one. But if you're not so sure and you'd like to see where the answers came from, keep watching and I'll go through them on the whiteboard. Looking at number 1 then, we've got x plus y equals 8 and 2x plus y equals 13. Now, if we do the top one, take away the bottom one, we could rearrange them like we did with the one on the slide, but I'm just going to keep them this way around for this one so you can see what happens. So we take away x minus 2x, leaves us with negative 1x. Y minus y leaves us with 0. And 8 minus 13 leaves us with negative 5. If we'd done the bottom one, take away the top one, we'd have got positive 1x and positive 5. But all we need to do to get back to that state is to multiply everything by negative 1, giving us x equals 5. Then we substitute that x value back into either one of the equations to find the y. So x plus y equals 8 becomes 5 plus y equals 8. So y is 8 minus 5, which is 3. Don't forget to sub it back into the other equation to check your solutions. So 2x plus y is 2 lots of 5 plus 3, which is 13, and yes, that matches the equation, so we're okay. Number 2, we've got 2a plus 3b equals 25, and 2a plus 5b equals 39. Now this time, if I do this minus this and this minus this, I'm going to get negatives for both of them. And it's the 2a's that cancel out and disappear. So I'm going to subtract the other way. I'm going to do the bottom one, take away the top one. So 2a minus 2a is still 0, that still disappears. 5b minus 3b leaves us with 2b. And 39 minus 25 is 14. So if 2b is 14, then b must be 14 divided by 2, which is 7. Substitute that back into one of the equations to work out what a is. Let's use the top equation. So 2a plus 3 lots of b is 7 must give us 25. And of course 3 7s are 21. So 2a must be 25 minus 21, which is 4. So a must be half of 4, which is 2. Check by subbing into the other equation. 2a plus 5b is 2 times 2 plus 5 times 7, which is 4 plus 35, which is 39, and that matches this equation up here. So we know we've got it right. And for number 3, 3x plus 2y equals 13. And 3x plus 5y equals 10. Let's subtract. We've got 3 x's on both, so they disappear. 3x minus 3x gives you 0. 2y minus 5y gives you negative 3y. And 13 minus 10 gives you positive 3. So if negative 3y is 3, then y must be 3 divided by negative 3, which is negative 1. Sub that back into either equation. Let's use the top one. So 3x plus 2 lots of negative 1 gives us 13. And of course, 2 lots of negative 1 is the same as minus 2. So we need to add 2 to both sides. 3x is 13 plus 2, which is 15. So x must be 15 divided by 3, which is 5. Again, sub back into the other equation to check. So 3x plus 5y is 3 lots of 5 plus 5 lots of negative 1, which is 15 minus 5, which is 10. and that matches the equation, so we're done. Okay, in the next video, we're going to take it up a step and start considering minus signs.